All right, my name's Taylor Gawthorp. I'm studying mechanical engineering at Bradley University currently. And this summer for my internship, I was located here at Moraine Valley, working on a water audit as a part of their commitment with the billion-gallon water challenge. So a little bit about Moraine. It is a commuter campus. There's about 36,000 students enrolled and about 720 faculty and staff. To give you an idea of some of their other water efforts that they've already put into place, they converted most of their landscaping water use to well water here on the grounds. And then as well, they implemented hydration stations to reduce those Hinkley contracts, reducing the water use there as well. All right, so to begin with all of the water use talk, I guess you could say, from the water bills, I found some of our current average annual use cost and our CO2 emissions. So I did one fiscal year of the water bill usage, starting in June, going all the way to July of 2015, so June 2014 to July 2015. And we do see, as you can see, about $1 a year increase in the cost of water. So that means that as we keep going on, the cost of water is going to keep increasing. So we obviously need to do something about this to reduce our water impact, reduce the cost of water for each year. So our average annual water use in kilogallons is about 145,000. Our average annual water cost with the cost of water, those two costs is $793, we'll call it, for 2014, and the $872 for the 2015 is around $1 million for a year of water use at the college on the college campus. And then our average annual water use carbon dioxide emissions is about 460 metric tons per year. All right, so my goals for this internship, I obviously just wanted to reduce our campus-wide potable water use. In doing that, I wanted to identify and understand our current water fixtures and the use that we have with those, identify the best water-efficient retrofits for our pre-existing fixtures, and of course produce a useful water savings tool for Moraine Valley to use currently and for the future. As well, one of my other goals was to identify and understand Moraine Valley's water use in energy metrics so that we could kind of understand our impact and what we could reduce as far as greenhouse gases go. My focus for the internship, I wanted to stay mainly in the restrooms, the kitchens, and the classrooms. As you can see in this graph here that I actually got from the ISTC website, a lot of about 37% of college campus water use is strictly in the restrooms. Then goes down to the cooling and heating, which I did not really focus on for this internship this summer due to time and other reasons that I'll talk about later. The landscaping, which I already said, we converted most of our water use to the well water. And then the kitchens and other, which I did take into consideration for my internship this summer. There were 8 out of 13 buildings that I audited this summer. Those 8 out of 13 buildings are represented with the circles here on this campus map. All of these buildings were identified by campus operations as the most opportune buildings for me to look at, whether it was the oldest, the ones that haven't been renovated, things of that sort. All right, so in order for me to get the data on all of this, I had to get my hands wet, literally. So of course, going into the men's restrooms, I can't just barge in there. So as you can see, I had this cool little sign, it's temporarily closed, and my little cone, as well as my little caddy that I carried all my instruments in. Although I had the sign, it didn't necessarily stop the men from walking in when they had to go to the restroom, but that's okay. So for the faucets, I showed this picture just to give you guys an idea of exactly what data I was collecting as I was going into the restrooms. So of course I needed to know what building I was in, room number, the position that the faucet fixture was in as well, the manufacturer of the faucet, so I could go back and look at model numbers and things of that sort. And then getting more into the water use, I needed to know the gallons per minute that the faucets were flowing at so that I could make the comparisons later. Of course, if it was leaking or broken, what kind of faucet it was, if it had an aerator, if it didn't, and any notes that I needed to have on that. As well, with the faucets and all of the fixtures that I was looking at, the leaking and the broken sections were very important, because if a fixture was leaking or broken, that's a lot of water that is being wasted. If it's leaking all the time, that needs to be fixed. We need to stop that water from being wasted, like I said. So each week I was reporting those leaks and those broken aspects to the campus op so they could get out there as soon as possible to stop that. All right, so here are some pictures of me in action here. So like I said, I needed to know if there was an aerator, what flow rate it was running at, things of that sort. So in the far picture, I'm down there at the faucet with a little mirror, reading the aerator, seeing if it's working properly, if the flow rate's listed, the model, things of that sort. In the middle, someone mentioned about the bags. Michael, I think it was you. The bags in the middle. What you actually do with the bag is, you can see in this picture, you put the bag under running water for 5 seconds. That gives you, on the bag, there's all these numbers here. That'll give you exactly the gallon per minute flow rate that the faucet or the shower head or the pipe, for Michael's case, is running at that way. So that gave me an idea of what all of the faucets were running at. Further, here is my sheet that I created for the flush valve toilets. Again, the same type of thing, building room number, manufacturer, but with the flush valve toilets, the way in which you measure how much water is being used from this is measuring the time that the flush valve allows water to flow through it. So when you flush a toilet, you obviously see the water starts to come. At that point, you wait until you hear the closure of the flush valve, and that is when the water stops going through. So I had my little stopwatch, as you see here, hardly I guess, and I would just go to the toilet, identify what the model number of the flush valve was, and then flush it, start the timer. And unfortunately, I had to put my head pretty close to the toilet in order to hear when that flush valve was closing. So it probably wasn't the most clean thing to do, but it worked, so we're all good there. Again, with the urinal, same thing as the flush valve toilet, it is still a flush valve. So again, the water flowing from when you flush it all the way through until when that flush valve closes and the water stops. And here I am again, very, very close, dangerously close to a urinal, which I had never been that close before or even known what they were really like. So I'm very educated on urinals now, if anybody has any questions about those. So like I said, once again, just timing that flush valve. Once I had all of that data that I had handwritten down from going around to the restrooms and the kitchens and things of that sort, I went back to this water audit spreadsheet that I was given by Rick, actually. It's an EPA water audit spreadsheet that kind of just lays out everything, allows me to separate by room number, separate by building, by fixture, the flow rates and all of that good stuff, just so that I can keep everything organized, go back and see whatever I need to see as quickly as possible and as efficiently. One thing I also want to point out is, as you're probably wondering, how do we get time that a flush valve stays open to the gallons per minute, or gallons per flush, excuse me, that are actually running in the toilet? Well, when you put the flush time into this water audit spreadsheet, it automatically generates the volume. The volume is exactly that, the gallons per flush. So that's how I got my gallons per flush for my calculations. All right, so after going through all of those bathrooms and kitchens and things of that sort, this is what I found. So at the bottom on the horizontal axis of this graph, you'll see the buildings in which I listed previously of the buildings that I traveled to get my data. And you'll see about average for the entire, for all of the buildings that I audited, it's about, we'll say 1.75 is an average flow rate for a faucet. Keep in mind that is the bathrooms, that is the classroom, laboratory faucets, that is the kitchens. So 1.75, we don't really know what that means. To give you a better idea, the red line is the industry standard for water efficient faucets. That is for restroom faucets. So keeping in mind that I did do some of the of the classrooms and some of the kitchens. It may be a little bit higher than the 1.5, but most of my data came from just the restrooms, and seeing that we have on average about 1.75, whereas 0.5 is the water efficient standard, we obviously see there's room for improvement and something needs to be done, okay? Also, just to give you guys an idea, Building M down there, all of the restrooms have already had 0.5 gallon per minute aerators installed in them. So every single faucet that I went to, put the bag under in the restrooms was 0.5 gallons per minute. Building M is also listed right here. In their kitchen, they have a large kitchen, culinary kitchen for students to learn. There was 5 faucets that did not have aerators. On all of those 5 faucets, the average flow rate was 5 gallons per minute, which is water just flowing directly out of the faucet, no aerator, nothing of that sort. And that brought the average for Building M all the way up to that 1.75 mark, whereas all of the restrooms were at 0.5 gallons per minute. So that gives you an idea of just how much one faucet, let alone 5 faucets, impacts water use for a building. All right, so we again move on to the flush valve toilets. So we can see all of the bars in the different buildings showing exactly how long in seconds the flush valves are running. And then again, in the red, we show the water efficient standard for flush valves, which is about 5 to 7 seconds. Once I entered all of that data, the time in seconds, like I said, from the water audit spreadsheet, it gave me the gallons, which you can see here. The EPA WaterSense recommends about 1 to 1.6 gallons per flush in a flush valve toilet for restrooms. So that is again where these red bars are, and we can see clearly there are way more gallons per flush being used in these restrooms than there should be. Same thing with the urinals here. They're a little bit closer than the toilets were, as you can see. Once again, for urinals, it is about 5 to seconds time for an average flush to be water efficient. And again, for urinals, about 0.5 is gallons per flush is water efficient standard. It even goes down to no water at all. So 0.5 is a conservative estimate of where we should be, and still we are way above that where we should not be. All right, so in order to do my calculations on the current annual use, I had to base them on some estimations. Obviously, it was based on just the buildings and the facilities that I audited, as well as the number of students and faculty and staff on the campus and the number of days. That comes into play. So we can look at how many people are here, how many people are using the bathroom each day, and how many times each day, things of that sort. So the average time a person uses the restroom a day. For that, I actually created a survey. I sent it to some of you EPA interns to see how many times people are going to the restroom. And that ended up being about 2 times a day. That taking into account that faculty and staff are here 8 hours a day, they may go 4 times, and a student may be here 4 hours a day and only go once. So I just kind of went into the middle, wanted to keep it conservative, kept it at 2 times a day using the restroom. An average time a person washes their hands, again, that came from the survey and some research as well. So the average time is about 30 seconds that you are running your hands under the water, washing and rinsing. All right, so getting into the calculations a little bit more. As you can see, all of this up here is the model that I used in Excel to calculate all of the water use. At the top, you see the total people here, the days, and then the faucet flow rates at the very top. So in order to calculate for a year, we just take the faucet runtime, multiply that by the number of people using, the number of times used, and then the flow rate, and that gives you the total kilogallons used per year, depending on how many people in each semester and how many times they go to the restroom. We take that and we multiply that by the cost of water, which all of my estimations were based on that 2015 cost, which was the $872. So you just multiply your total kilogallons times the cost, get your total annual cost of your water. So after doing those calculations, my current, or Moraine Valley's current audited faucet use was about 10,000 kilogallons a year. That translates to about $88,000 a year just in faucet water use alone, and that is about 32 metric tons of carbon dioxide use. And keep in mind, this is carbon dioxide emissions, excuse me. And keep in mind, this is just for the faucets. Moving on to the flush valve toilets. Again, you can see my model. Everything is kind of laid out there. And again, this is just times flush times the number of people using, the number of times the toilet is flushed, and then the gallons per flush. One thing I do want to point out here is that for me, to get the calculations on the toilets, I had to assume that men and women use the toilets. So men, I said, flush the toilet only once a day. And then women, like I said, the 2 times a day. You'll see this later in how I estimated that everyone uses the restroom twice a day, that a male uses the toilet once a day and the urinal the other time of the day, if that makes sense, hopefully. So like I said, multiply all those things together, get the total kilogallons used, and then multiply that by the cost of the water. After doing that, the current audited toilet totals are, for the water use, it's about 37 kilogallons per year, which translates to about $323,000 a year for the toilets, and then 118 metric tons of carbon dioxide emissions. Again, similarly to the toilets, you multiply times flushed by the number of times using, number of people using, number of times used, and then the gallons per flush. And like I said, for the males, they're the only ones using the urinals, I'm assuming. And so, you never know. So I said they would be using them 1 time a day. And from those calculations, the total water use annually for urinals is about 5,000 kilogallons a year, which translates to about $45,000 a year and 16 metric tons of carbon dioxide emissions. Okay, since I only audited a certain number of buildings out of the entire campus, it's important for us to know how much of the water use I actually tackled. So from the water bills, as you can see in the purplish blue on the left side farthest from me, is what I calculated as our total water use in kilogallons per year from the water bills. So what we're being billed for every single year. On the left side in the lighter blue, closer to me, of the audited areas, that is just the totals that I found from all of my calculations on what I actually audited. And that is actually only about 36% of the total campus water use. So what that means to us is that obviously if, say, another EPA intern came in, they would have the rest of the campus to audit, causing obviously more coverage, as well as some of those areas like the boilers, the cooling towers, and things of that sort, where a lot of water is being used, they could as well be taken a look at. So from that 36% of the total water usage that we're getting from the water bills, 7% of that is from the faucet water, 25% is from the toilet water, and only about 4% is from the urinals. All right, so what we're all interested in is how do we change this? So my recommendations for the campus are that we install 0.5 gallon per minute aerators on all the faucets. Get all of the faucets down to that water efficient industry standard of the 0.5 so we can save as much water that way. As well, for the manual and the automatic flush valves, so the toilets with just the handle, as well as the toilets that go off automatically when you move. Install the dual flush handle, which I think most of you guys have seen. You'll see it in the pictures coming up. It's the ones where you have an option to do the 1.1 gallon per flush or the 1.6 gallon per flush. And like I said, we'll see that in the next couple slides. And then as well, for all of the urinals, we should install 0.5 gallon per flush flushometers. All right, so like I said, I'm suggesting that we highly suggesting that we convert all of our faucets to the 0.5 gallon per minute flow rate aerators. Right now, as I told you, building M already has all the 0.5, so that one is taken out of my calculations. So we would need 211 of the 0.5 gallon per minute aerators to implement into the other buildings that I saw they needed to be implemented in. The cost for each of those is $324, and that has a payback period of only 3.85 days. So once those are installed after purchasing and everything, it takes 3.85 days for us to gain all that money back. This is what I was talking about when I said the dual flush handle. So this is for the manual toilets that actually still have the handle on them. So as you can see here, you can flush up for liquid waste and down for solid waste. That comes into play with the 1.1 and the 1.6. So if it's liquid waste, it doesn't need as much water going through to clear it out. 1.1 gallons will do, and down 1.6 gallons. So we need 141 of those at a higher cost of $59.36, excuse me, for each one. And then for the automatic toilets, again, the dual flush handle with either option, the 1.1 or the 1.6. This one is a little tricky because obviously it is a sensor. You don't necessarily always get to decide with the buttons. But the cool thing about this is that it actually times you. So the longer you're sitting, if you're sitting for a long time on the toilet, it'll do that 1.6 gallon per flush. And if you're sitting there for a few seconds, then it just does the 1.1. We need 43 of those from the buildings that I audited. The cost of those is $281.95 each, and the payback period for both of those, the manual and the automatic flush valves, is 1.04 months. For the urinals, again, I spoke about going to the 0.5 gallon per flush urinals. So we would be moving to the high efficiency urinal flushometer. We do need 60 of those at a cost of $370.33 each, and that does have a little bit longer of a payback period of about 7.84 months. All right, so after we would implement all of those, as you can see on these graphs, the blue up here is the current, so what I initially showed you guys in the other graphs, that's where we are right now. After all of the recommendations, these are the estimated totals where each of the areas of water use would be at. At the bottom you see there's an annual savings for each of these. So the faucets is about 8,000 kilogallons. The toilets are about 27 kilogallons, and then the urinals is about 4,000 kilogallons of water saved by implementing those recommendations. All right, so the project total for the entire, for doing the entire project, that's subtracting the cost of purchasing each of the retrofits for each of the fixtures. So the total estimated water savings annually after implementation of the recommendations is about 39,000 kilogallons per year. So what does this mean? That's just a number. No one actually knows how much water that is. As you can see here, that totals to about 58.3 Olympic pools, which is a massive amount of water. I've never personally seen one of these in real life, but on TV even, it looks amazingly huge. Even further, that's about 51.3 seconds of water falling over Niagara Falls, which is a ton of water. That's almost a minute of water at Niagara Falls, and that's crazy. All right, so the dollar savings, this is as well important. Not only just the water, we also want to know about the cash. So for the faucets, the savings per year is about $66,000 a year. For the toilets, about $236,000 a year, and the urinals about $34,000 a year, giving us a total estimated savings annually after the implementation of the recommendations of $336,000 per year, and the total project gives us a payback of about 1.6 months. So everything altogether is about 1.6 months to pay us back there. So what does that mean? That's a lot of money. Okay, what can we do with it? This is a community college. We do need scholarships for students. Everybody needs to go to school. All of that extra savings would be great for scholarships, for grants, for textbooks. And as well, I did a small calculation of how many Campus Connection bus passes that would be for students, and it came out to be about 2,000 bus passes for students, and that's a semester-long bus pass to get you from your bus stop by your house all the way to campus, which of course reduces the single occupancy vehicle use and further reduces our carbon dioxide emissions, which is wonderful. speaking of carbon dioxide emissions, the total reduction per year for each of the following areas is about 24 metric tons per year for faucet use, 86 metric tons for toilet use a year, and then about 12 metric tons per year for the urinals. That totals to about 122 metric tons of carbon dioxide emission reduction. So what does that mean as well? As you see here, that same amount of carbon dioxide emissions can be seen as 14,000 gallons of gasoline consumed, 132,000 pounds of coal burn, and so on and so forth. So it does make a huge impact from implementing these recommendations. All right, so I would just like to thank, obviously, the EPA and everyone at Moraine Valley. I obviously couldn't do this alone. I had a lot of help. Stephanie was wonderful. Andy's over there. Rick, our campus ops. For the calculations, I even needed some help from our tutoring center, so I had some help from over there. And everyone in the library was so nice and so welcoming for me here. As well, Nate Keener from Lewis and Clark College helped me out with some of my questions regarding water, and Bart Bartles at the ISTC was also wonderful. Any questions? Yeah.
Thank you. I really like the way you presented the data and everything.
Thank you.
To us. I had a few questions.
Mm-hmm.
What is the carbon dioxide emissions based on?
There is an EPA calculator that I was given, and that is based on how much the kilogallons of water. So you insert the kilogallons of water, and it's based on the state that you live in, and just spits out the carbon.
The energy.
Yes, it's the energy that it takes to clean the water at the wastewater treatments, the energy that it takes to deliver the water to the campus. Mm-hmm.
And then on the toilets, the retrofits, there was two concerns I had. One was, did you account for labor?
I did not count for labor. I was talking to Stephanie about that, and she was saying yesterday, we were trying to see if maybe it would be like an internal cost, so people that work, like the operations staff would just be working on it. But even still, I feel as though with the savings that we have, if we had to hire a company to do it.
It might extend your payback.
Yes, it would definitely extend the payback a little bit, yeah.
And then on the toilets themselves, are those all the tanks?
Mm-hmm.
1.6-gallon tanks?
They are not. The toilet bowls are all different sizes. I only found, I'm estimating here, I only found about maybe 10 maximum toilets that were 3.5 gallon per flush bowls. Everything else that I found was like 1.6 gallon per flush. And I talked to Nate Keener at Lewis and Clark, and he told me that although the bowls are like the 3.5 gallons, the water flowing from the flush valve, the 1.1 and the 1.6, will still be enough to get the waste out of the toilets. Yes?
Is it your impression that most people know that there are two ways to flush and that it makes a difference? The reason I ask is that Alan did some experimentation with signage,
Mm-hmm.
and I was wondering if there were little signs that
Right.
said, that people would look at it and go, oh.
Yeah, I mean, I've personally seen that handle, and it's green, so that kind of automatically you're like, oh, it's a green handle. It kind of like brings that to your attention. But on the handles usually, as well, I've seen there's a little sticker on there that says it has a line and it has. I'll show you. Maybe if I can get back to it. Yeah. Right here. So there's a little sticker there. So if someone is really curious about this green handle, they can see, obviously, okay, liquid waste, I shouldn't use as much water. And then that tells them to flush it up and then flush it down for solid waste, But you never know. I think maybe putting signs in the restrooms like right above it would even be more effective. But I think the green handle does draw your attention to it a bit. Anybody else?
Go back to the slides that way in the beginning with the pie chart, please. said that about 36% of college campuses' water use is represented in restrooms, and that's primarily where you spent your time. And looking at our water footprint, that's what you found, right? So
Right.
You found about 36% of our water usage, and that was only 8 of 13 buildings. So
Exactly.
possibly with the kitchens on top of it,
Mhm.
I think that we're actually pretty representative of.
Definitely. I definitely think that. Yeah, and I tackled some of the kitchens and some of those classrooms as well. So definitely, even if I just looked at restrooms in all of those buildings, we'd still be close to that 37% with the 36 that we covered. Mm-hmm.
Taylor, just two things.
Uh-huh.
I want to thank you on behalf of the college for this work. This was, as we began this work, our director of campus operations, Rick Brennan, as you know,
Mm-hmm.
was anxious to get the results. I'm sorry he couldn't be here today. I know
That's okay.
He'll be interested in this, and the payback is well worth it.
Mm-hmm.
I have to mention that, and I was mentioning back here, that the real opportunity to save money is if we collected water and used rainwater to flush it.
Mm-hmm.
It'd save a lot more.
That would be wonderful, yes. A lot more money.
I've seen that environment as well. So this was a great project, and we thank you for your work.
Thank you. Thank you.
And what's the billion-gallon challenge? How does this fit in with the billion-gallon challenge?
So the Billion Gallon Water Challenge is with the ISTC, and they're trying to save 1 billion gallons at college campuses. I don't think they have an actual time frame set, but they're just basically it's just a reason to get college campuses to do a water audit to see how much water they can save and how much money they can save.
Okay, so you're reporting your results back to them, and then they consolidate.
I will probably be sending my results to Bart, just so that he can see. I don't know, Stephanie, are we supposed?
There's no formal reporting with it, so it's just kind of an awareness campaign,
Mm-hmm.
Yeah.
from what I understand.
Right.
So, but I mean, if we implement and can benchmark and show the savings by next semester or whatever, we'll
Mhm.
definitely
Show.
highlight it,
Yeah.
tell the story.
Stephanie, this could be a good project for you to present in ICCH,
That could be.
you know, because they always have the sustainability track. And we could kind of share the results of Taylor's work. Maybe you could even kind of co-present with it.
That'd be fantastic.
And then, you know, then you're reaching 39 community college districts in Illinois.
Right.
Yeah, FYI, ICCA is community college administrators.
All right, anybody else? Okay, I'll show this slide just one more time so you can see. If you have any other questions or anything, there's these wonderful websites to help you guys out as well about some water use and everything. All right, thank you so much.